final topic for today. We only talk about half of them. It's about linear regression. So now we have a beta 0 and beta 1. We talk about the P, R, Y, given beta 0, beta 1, and X. Okay. Now we finally go to the only model we will talk about today. We want to find the beta 0 and beta 1. But what we have is this. So we can get the Y. Actually, this is Y height. Remember, if we have some point here. Here is Y. Here only one feature here. We fit a line here. So the prediction is not exactly equal to the value of a true label, even you using a best fit line, right? So what we will do to make this equal to Y rather than the predicted Y is we add some error term epsilon. Epsilon is equal to, it's like this. The predicted value is here and the true value is here. So the epsilon is equal to maybe the -2. If here is, say here is 5, here is 3. So epsilon should be -2. So then it can become the true value, right? Okay. So now what we want to know is the distribution of Y, but we don't know distribution of Y, but we can reasonably assume the distribution of epsilon. Anyone can tell me what's the probable distribution of epsilon? If this is the best fit line, the epsilon should not be far away from, far away from 0, right? It could not be, far away, like the point is here, then the epsilon will be very, very big. No, it won't be this line. If the point is here, the line should maybe be something like this. So the epsilon is less probably, it's less likely if it's far away from 0. It's mostly around 0. So if I draw a distribution for epsilon, it maybe look like this. Here is 0. If it's around 0, epsilon should have a high probability, right? If it's far away from 0, the epsilon should have a less probability. So I think now you know what's the distribution of epsilon. We can assume the distribution of epsilon is just follow normal distribution, and the mean is 0. So that is a standard normal distribution, right? So now I can say epsilon follow standard normal distribution. I don't know variance, but I know mean is 0. Okay, so now have a little bit thinking about what's the distribution of Y. Now we know the distribution of theta. What's the distribution of Y?
I'm not sure. Is it normal distribution n and b1 plus b0 plus b1x?
Yep, that's it.
Yeah, it's all sigma. I don't know.
Yep.
Variance.
Yep, because this is just like a constant things because we're given b0, b1, and x. So this is a constant. You add a constant to a random variable. So the only thing it will change is the mean. So the mean here, variance doesn't change. So that's it. Okay. Let me erase this. Okay, belong to this, right? Okay, so I want to make it into functional form. Anyone can tell me what's the function of the PDF of the normal distribution? It's equal to W, oh, sorry, not W, it's like 2 pi variance square 1 and something else. What's that? It's E, and it's like I square, and here is if X is random variable, but now what's the random variable? The random variable is X, sorry, the random variable is Y, then minus mean. What's the mean here? Mean is this one. So minus that 0 plus that 1x square. This square. I think, yeah, I should give a minus here. This is a PDF of power distribution. So now we can see what we want to maximize is this. Okay. Now I can erase. Now we are nearly finished this objective. Well, what's this? Let me simplify this. This is a constant, right? We don't need to care about the constant. And here we have E. This is exponential function, right? If we want to maximize the exponential function, this should be maximized or minimized. Remember the exponential function is like this. So if this one become bigger and bigger, the whole value will be bigger and bigger. So we want to maximize it. So we want the whole value become bigger and bigger. So we want this become bigger and bigger, right? So we want this become bigger and bigger, but this is constant. We don't need to care about that. But here there is a negative. So if we want to make the negative of this thing become bigger, we want this thing become smaller, right? So finally, what we want is we want to minimize this thing. Oh, sorry. Okay, we want to find the smallest this one. So we can maximize the whole one, the whole probability. Okay, have a look. Let me see if you have any. I don't think there's enough information to graph it on 2 axes. Okay. It's function that take beta 0 and beta 1, the gradient. Well, so now here, actually, this is called ordinary least square. Now from maximum likelihood, we got this. This ordinary least square is specific for a regression problem. So you know how coincident it is. We use maximum likelihood, then we derive to least square. You know, least square is very famous paper in the history. But the author of least square, the mathematician, doesn't think about the maximum likelihood. But finally, they got the same thing. Actually, this thing is very intuitive, right? What's the objective? We want the prediction. Here is a prediction. We want the prediction, the difference between the prediction and the true label are very, very close to, if they are close to each other, minimize. So the model would be better, right? Sure. That's what we want intuitively. Okay, so now let me let me do the job to find the beta 0 and beta 1. Because here we finish the final objective function. This is final objective function, but we still don't know what's the beta 0 and beta 1. So let me figure out what's beta 0 and beta 1. Okay, so how to do this? How to find beta 0 and beta 1? Actually, we have a lot of data point, right? So I should do the summation. One hint is you can think about the calculus, and this is cojective function. Cojective function is like this, right? If you want to, if the minimum exists, how we can get this minimum? Here is a beta 0 or maybe beta 1, because if you put this inside the beta 0, if beta 0 is random variable, it becomes square. Beta 1 is also becomes square. So both beta 0 and beta 1 in terms of this function are cojective function, right? So they are always using the same form, beta 0 or beta 1. How I can find this, where this beta 0 and beta 1? Any idea? If we have a derivative, what's the derivative at this point? Yep, the derivative equal to 0. What's the derivative? You make a tangent line for the point, then this slope of tangent line is the derivative. Now this 0, right? Here, if you show here is not 0, not 0, until here is 0 at the minimum point. So that's how we can get these two variables. We need derivative, the function of beta 0 equal to the derivative of this. This is derivative, sorry. So how we can, what's the derivative of this? This should be 0, right? And also beta n. This is, I call this function is f at 1. This is should equal to 0. You can unmute yourself if you are familiar with derivative. What's this derivative? Actually, the summation, I can put summation here, it doesn't matter because that's derivative. You know, this z, this is, if you take it as z, this is z squared. If you use chain rule, don't use chain rule first, use the power rule of derivatives. If a function equal to fz equal to, let me make it bigger. If function like fz equal to z squared, what's the derivative of this? You can type in the message box, what's the derivative of this function? Is there always only one point where, yep, so for quadratic function, there is always one point where the derivative is 0. It can be minimum, it can be maximum. But that is for quadratic function. And if the function is different, it's not linear, actually, if you know here is a linear function, then we take the y minus this linear function, then it always be a quadratic function. So there exists one minimum and maximum value. But if you use neural network here, or if you use some maybe exponential function like ax, then I cannot guarantee that you can only have one minimum of maximum values, maximum of minimum points. Okay, so what's the result? No one know. It's actually equal to 2z. This is called power rule, if you remember from your statistics class. So this is z. So 2z, what's a 2z? 2z is 2z is this. So this is z. yi minus beta 0 plus beta 1 xi. So, but we have a minus here. You know, if you have function like fx equal to ax, then the derivative of x is equal to a, right? Here the a is -1, right? So that's why I put y minus here. Okay, so now, yes, you're correct. And now for this one, it's the same thing. The only thing different is we have a different constant. Here the constant is -1. Here the constant is become minus xi, right? So I put minus xi here. We still need the 2, right? So minus 2xi yi minus beta 0 plus beta 1 xi. Okay, that's it. Okay, so we need to, using these two equations, we can find beta 0 and beta 1. So just follow me to find what's the beta 0 and beta 1. Which one? Let me solve this first. I will put this at the bottom. We will look at this later. xi, yi, beta 0 plus beta 1 xi equal to 0. Okay, let me solve this first. What's that? Let me put the for brevity, I won't put this, but you know what I mean, right? It's summation. Yi. This is a minus b and minus beta. Sorry, not b. Minus beta 0 minus beta 1 xi. So this is 2 plus 2 beta 0 plus 2 beta 1. So actually, I can directly eliminate 2 because here is 0. I divided 2 here. I divided 2 here, so I can eliminate 2. Minus, I also can eliminate minus, right? So what we have is this. Then it would be easy. What's the summation of yi? Anyone know what's the summation of yi? Actually, you know. What's the summation of this, right? This equal to y bar. So what's the summation of y? Summation of y equal to n y bar, right? So now here is n y bar. What's the summation of beta 0? We sum the beta 0 n times, so it becomes n times beta 0, right? Here's summation of xi equal to n x bar, right? We put the constant here, beta 0. Sorry, beta 1. Then we can get 0. Now we can eliminate the n. Now we can get what's the beta 0? Beta 0 equal to beta 1 x bar minus y bar. Yep, that's it. That is beta 0. I think, let me check if I'm correct. Otherwise, if it's not correct, I will go into trouble in the later stage. Okay, I'm almost correct, but actually it should be the y bar minus beta 0 and x bar. So let me figure out. I actually I lose a negative symbol here. Yi, this is Yi minus n that's there. Then I have Yi. Oh, sorry. Here should be minus, right? Minus. So now the beta 0 should be, you put beta 0 on the right side, y bar minus beta 1 x bar still on the left side. So you have this. Okay, now this is correct. Hopefully we are all good for that. Now I solved the first equation. It gave me the x0. What's the beta 0? Now we need to solve the beta 1, right? Because we know what's the y bar and the x bar. Because we have training data, we just calculate y bar and x bar on training data. So let me see. We have a first achievement. That is beta 0. Now let's guess what's the beta 1. Then we finish. Let me move this equation above to solve this. I minus beta 0 plus beta 1 xi squared equal to 0. As before, I will eliminate minus 2 because here is 0, so doesn't matter if I have minus 2 here. So now I expand this parentheses. The things in parentheses is xi, yi, and minus. I do minus here, I do minus here. So you come beta 0 xi. I do minus beta 0 x. Why I don't have this here? So I don't have the square here. So beta 0 xi. So I have xi squared. Then I have this equal to 0. So let me eliminate this. I don't eliminate this for the first term. It's still xi times yi, but let me eliminate this for this. Sum of xi is equal to x bar n, right? We have beta 0 here. Then summation of the xi square. Now the random variable is xi square, not xi, but the same thing. We have this random variable xi square. Then we take the average. Then we times the number of example. Of course, put the beta 0 here, and we have 0. Okay, now we have beta 0 here. We already got what's the beta 0. Let me substitute this beta 0. Let me see if there are any questions. No. If you have questions, just write your question in the message box. So I will look at it later. Beta 0 is y bar minus beta 1 x bar n x bar beta 1 n x square. No I because it's a mean. Okay, so now let's expand this minus n x bar y bar minus, so plus n beta 0, not beta 0, beta 1, and x bar times x bar is equal to x bar square, right? So put this first term back, then put the last term back. So now we know what's the beta 0, right? No, beta 1. The beta 1 x bar square minus n x square bar. Then this is, let me put this on the right side. This is left side. So right side, we can have x bar, y bar, then minus summation xi, yi. Okay, we don't need this. This is the original equation. So now we know what's a beta 1. So we will finish now. What's a beta 1 here? Beta 1 equal to this one divided by this one, right? I just want to be a little bit lazy. So I just say this one, beta 0, or beta 1 divided by this one, right? And x bar square. Here have n, so I put n outside. Okay, now we finish. Then have a look. If you need some clarification, let me know. Otherwise, I will erase this because we basically got the final answer. Oh, good. I will. You can take a screenshot. So if you have question, we can you can share me all these steps, so we can have a step-by-step look. Okay. If you want, take screenshot. Let me. Okay, I will do this. Okay. Now we have beta view. Actually, I still need to simplify it further because I have a x squared bar. I want to eliminate this. Can you think of what is this? What is this? Anyone know what this is? The x bar squared minus x squared bar. Residual error square. Nope, it's not residual error square. It's variance. Okay, let me find a. Let me share the screen. You can see my screen now, right? Let me know if you can see the screen. I think I already shared. Yeah. Let me go. I own proof that is a variance. If you are interested in why it is variance, you can prove it or find some improvements on Google, because that is very common one. See, this is variance of random variable is equal to this. This is expectation. Expectation is average. So here you see it's x squared average. Here is average square. So this is actually the variance. I just lost my word. Variance. Okay. So let me remove this negative. Okay, this is negative variance. I remove this negative, then I need to convert the position, right? So let me convert the position. Is minus nx bar y bar. Oh, sorry, I don't. I still share my screen here. Let me go back to. Okay. So now you should see my. Okay, let me remove it. I will. As you see here, I will move it back and X bar, Y bar. Yeah. Here. This is, as I showed you before, this is a negative variance. Okay, so let me remove this. This is negative variance. Okay, negative variance here has n. I don't want this negative. Let me eliminate this negative. Then I have to change the position. This 210 because I just remove the negative, right? So all good. So what's the variance? I think everyone remembers the variance. Variance is n divided by the xi minus x bar square, right? So this is variance. Let me move this, use this variance to replace this one. I have n here, so I remove the n. Okay, now this is become more beautiful. This is our final outcome of beta 1. Let me change this one to this one. I yi minus n x bar y bar. And here is xi minus x bar here. Okay, done. Now let's see, we know xi, we know y, training data, training label, we know x bar, y bar, we know xi, we know x bar. We know x bar, we know y bar, we know beta 1. So finish. Oh, yeah, I think hopefully you can see it because I think it's a little bit small. Any question for this? If it's not clear on the board, just let me know. Because I know math is, if you lose one step, maybe you'll lose a lot of steps. I can use the variance to get some more information at inference time too. It's almost like a confidence interval. Yeah, you can get variance. But what random variable you want to calculate it on variance for using variance at inference time? You can think about it and type it in the message box. Okay, so let me show you the code. Now I have solved it, right? Let me implement it in Python. Actually, I already implemented in Python, but I will let you see the code is aligned in with what we just derived before. Okay. This is my paper, not my package, regression. So I call it ordinary least square. You know, I talk about what's ordinary least square. So you see here is the equation. Here is a formula. It's the same as what we derived. Have a look. Then the y mean minus that 1 and x times x bar. Just have a look of these two, and it is equal. But here is x. let me also, I hope you just have a screenshot of what I wrote on board, because I'm not sure. Can you see the board and my screenshot simultaneously? Give me some up if you can see the board and my screenshot simultaneously. So. Okay, you can't see both at the same time. So, okay, so, okay, so let me copy paste the code in the if you can. That's a problem when I do some workshop on the, on the online, because I can't show you both. But here's a calculate mean and mean. Now here is the equation, Python equation. So let me share it here. Okay, so I will stop sharing. Now let me go back to this. So you see, I calculate the beta 0 equal to y mean minus beta 1 times x mean. That's the equation we derived here. Then for the beta 1, we have a sum of x mean, sum of x minus x mean multiplied by y minus y mean. It's a little bit different because actually they are same. Let me show you. Actually, they are same. Okay. So this denominator is the same as the code here. The code here is summation xi minus x bar multiply yi minus y bar. Yeah, actually it's equal to xi yi minus y bar xi minus x bar yi plus x bar y bar. Then it's equal to summation of this xi yi. Summation of this is xi is equal to n x bar, right? So it's become n y bar x bar minus n x bar y bar. Here the same thing, summation of y equal to n y bar. So it's also minus n x bar y bar. So here is the summation of x bar y bar is equal to n x bar y bar. So here we have n x bar y bar minus n x bar y bar minus n x bar y bar plus n x bar y bar. So we can eliminate this minus and plus. So what we got is this, right? So this is equal to this, the thing I derived on the board, right? So actually this line of code, I show you in the message box, is equal to the numerator I wrote at the beginning. Okay. So that's it. That's then you can see the denominator. Denominator is totally the same. The summation of x minus x mean squared. So let me show you this is correct. I will share my screen. So let me go back to the code. Here is the function. Let me use this function for an example. Go back to this notebook. I create x equal to 1, 2, 3, 4, 5. Then I create y according to the true beta 0 and beta 1. I make true beta 0 is 5, true beta 1 is 10. So I create my y is equal to true beta 0 plus true beta 1 times x 1, 2, 3, 4, 5, right? So now I I use this ordinary least square estimate. Actually, this is using the formula of beta 0 and beta 1 we derived. So we got beta 0 and beta 1. If the formulas are correct, so we should got beta 0 equal to 5, beta 1 equal to 10, right? Let's have a look. Yep, beta 0 equal to 5, beta 1 equal to 10, right? So that's it. When you use a linear regression, you can just remember these two. You can just need to remember these two formula. So you solve linear regression.